In a remote quarry, long before iron sang against stone, a block larger than a modern truck was freed from bedrock with no blade, no wheel, no written plan. Why does the stone still bear no scars of force? Why do the joints close tighter than machine tolerances? Why do the marks contradict the tools we were taught to trust? Why does patience appear where power should be? Before we dive deeper, ignite that like button and prepare for the revelations to come. Tell me in the comments where you are listening from, what time it is there. And as always with our videos, the visuals are here to add context, but they aren't necessary to follow along. Thank you for always having our back. Prepare yourself, and let's dive in. Stone was already being shaped with intention long before blades hardened and rulers were marked. Across distant landscapes, blocks weighing tens and sometimes hundreds of tons were separated from bedrock, trimmed, moved, and set with a care that does not look rushed even now. The surfaces do not shout effort, they whisper restraint. Where violence would leave chaos, these stones show calm continuity, as if time itself had been invited to participate. The marks that remain do not resemble frantic blows or hurried cuts. They appear measured, repeated, almost meditative. In many ancient quarries, the first lesson is visible before any monument is reached. Unfinished blocks still cling to the earth, frozen in the moment where intention met limitation. At places like Aswan, the granite does not crumble or splinter wildly. Instead, it separates along long, shallow channels with rounded profiles, grooves that suggest guidance rather than attack. Granite, a stone ranked high in hardness, resists sudden force. Copper, the metal often assigned to these periods, bends and deforms long before granite yields. Yet the stone bears witness to control, not defeat. Experimental archaeology has demonstrated that sand, rich in quartz, can abrade granite when held and guided, even by soft metal or wood. The process is slow, but slowness leaves its own signature. Abrasion removes material evenly. It rounds edges before flattening planes. It produces surfaces that appear smoothed rather than struck. When such marks repeat across continents and centuries, coincidence becomes unlikely. What appears instead is a shared understanding of how stone responds when pressure is distributed across time. At sites separated by oceans, similar patterns emerge. In the high Andes, polygonal blocks interlock with such intimacy that their seams resist even the thinnest blade. These stones are not uniform rectangles. They are complex, multi-angled forms, whose faces curve subtly to meet one another. The contact surfaces are smooth where they touch and left rough where they do not, suggesting selective attention rather than wholesale finishing. Each stone seems to have been tested repeatedly against its neighbor, removed, adjusted, and returned until gravity itself confirmed the fit. This process favors patience over strength. A stone pressed gently against another reveals its own errors. High points scrape, low points remain untouched. The stone becomes its own measuring instrument. No abstract geometry is required, only repetition and sensitivity to feedback. Over time, the fit improves. The final joint records not a single decisive action, but hundreds of small corrections. This is precision born from dialogue rather than command. In Egypt, the same quiet discipline appears on a different scale. The base of the Great Pyramid deviates from true level by less than the width of a finger across each side. Its alignment to true north misses by only a few arc minutes, a precision that rivals modern surveying. No magnetic compass existed to guide this orientation. Instead, simple principles were applied relentlessly. A plumb line establishes vertical by obeying gravity. Water, poured into shallow channels, finds level without argument. A stretched cord defines straightness across distance. These tools are humble, yet when used consistently, their accuracy compounds rather than drifts. Consistency is the hidden force behind ancient measurement. A cubit rod, whether carved from stone or shaped from wood, establishes length not by abstract unit, but by embodied reference, often tied to the human arm. When a structure is built using the same reference throughout, coherence emerges naturally. Errors do not cancel out by chance. They are prevented by repetition. A worker trained to the same motions day after day develops an internal sense of distance and angle. The body becomes calibrated through habit. This embodied knowledge leaves little trace. Wood decays, rope frays, sand scatters. What remains is stone, carrying the memory of actions without preserving the tools that enabled them. Modern interpretation often stumbles here, searching for missing devices rather than missing practices. The absence of metal instruments is taken as absence of method when it more likely signals reliance on materials that were never meant to endure. Transportation deepens this misunderstanding. Moving massive stone without wheels or engines appears impossible when imagined as a single dramatic event. In reality, ancient transport unfolded as a sequence of controlled adjustments. Reliefs from Egypt show statues hauled on wooden sledges, their runners sliding over dampened sand. Recent physical analysis confirms what observation already suggested. Wet sand stiffens, reducing friction and preventing buildup in front of the load. The stone moves not because force overwhelms resistance, but because resistance is quietly reduced. Sliding favors predictability. Rolling introduces instability, especially on uneven ground. A stone kept in continuous contact with the earth behaves more reliably than one lifted clear. Ancient builders seem to have understood this intuitively. Stones were shaped close to their final form at the quarry, reducing unnecessary weight. Transport paths were prepared gradually. Inclines were gentle. Progress was slow enough to allow constant correction. If a crack appeared, movement stopped. Time was not the enemy, it was the medium. Leverage amplified human control without inviting catastrophe. A long wooden beam can lift a heavy stone a few centimeters. A wedge placed beneath holds the gain. The beam is repositioned. The process repeats. At no point is the stone abandoned to gravity. Each increment is checked. The wedges, often wood or stone, leave little archaeological trace once removed. The beams decay. The method vanishes, but the result remains. In places where stones reached extraordinary sizes, such as Baalbek, the terrain itself may have assisted. Quarries located slightly uphill allowed gravity to participate in movement rather than oppose it. Temporary earth ramps extended the ground, supporting immense loads without requiring permanent infrastructure. Once the stone was set, the earthworks were dismantled and reused. The landscape absorbed the evidence. What emerges from these observations is not a single lost technique, but a system of attentiveness. Stone was not forced into submission. It was encouraged to behave according to its nature. Heat expanded it. Water cooled it. Sand wore it down. Pressure guided it. Sound, perhaps, offered feedback, as a clear ring differs from a dull warning of internal fracture. These cues were learned through exposure, not written instruction. Ancient societies transmitted this knowledge through apprenticeship rather than manuals. A child learned by watching hands, not by reading words. Over years, posture, timing, and judgment became internalized. Such knowledge is resilient while practice continues, yet fragile when continuity breaks. War, migration, or changing priorities can dissolve lineages of skill within generations. When that happens, the stone stands alone, impressive and mute. The temptation to imagine lost machines arises from this silence. It is easier to invent vanished devices than to reconstruct vanished habits. Yet the stone itself argues otherwise. Its surfaces show restraint. Its joints show dialogue. Its placement shows respect for gravity rather than defiance. These qualities do not require hidden technology. They require time, organization, and a willingness to listen to material. Across the ancient world, similar challenges produced similar solutions because stone behaves consistently wherever it is found. Parallel discovery under shared constraints explains convergence without invoking forgotten empires. Precision was not miraculous. It was maintained. The true achievement lies not in secret tools, but in sustained attention applied across generations. Stone remembers that attention long after the hands that shaped it are gone. Measurement in the ancient world did not begin with numbers written on tablets or angles scratched into diagrams. It began with reference. A vertical line established by a hanging stone never lies. Water poured into a shallow trench does not argue about level. A cord pulled tight between 2 points reveals straightness through tension alone. These principles do not depend on theory. They depend on consistency, and consistency is something the human body can learn to maintain. Across early stone structures, the quiet presence of measurement is visible in results rather than instruments. Floors remain level across distances far longer than any surviving measuring rod. Walls meet at right angles not because geometry was abstracted, but because proportion was embodied. A rope divided into equal segments can form a right angle when arranged into a 3, 4, 5 relationship. A simple triangle whose shape enforces order without calculation. The rope itself remembers the ratio. Once learned, the method travels easily, leaving no durable artifact behind. At the Great Pyramid, alignment reaches a degree of accuracy that continues to unsettle modern assumptions. Each side faces a cardinal direction with minimal deviation. No magnetic compass guided this orientation. Instead, the builders likely relied on the sky itself, observing the motion of stars around a fixed point and using repeated sightings to establish true north. This process demands patience rather than complex instruments. Night after night, small errors are corrected through repetition until the average converges on truth. The result is alignment embedded in stone, long after the observations ceased. This reliance on repetition appears everywhere careful measurement was required. In Stonehenge, the tops of the upright stones follow a continuous horizontal plane, despite their irregular shapes. The lintels that rest upon them meet precisely through mortise and tenon joints carved directly into stone. Once these stones were lifted into place, adjustment became nearly impossible. The accuracy had to exist before the lift occurred. This implies that reference was established and maintained throughout shaping, not corrected afterward. In the Andes, measurement takes on a more fluid character. Walls at Cusco and Machu Picchu do not rely on straight lines or uniform blocks. Instead, they follow the terrain, curving gently while remaining stable. Each stone carries multiple faces, each matched carefully to its neighbor. The geometry here is responsive rather than imposed. Measurement adapts to landscape rather than resisting it. The result is seismic resilience. When the earth moves, the stones settle back into place instead of collapsing. Such outcomes suggest a different understanding of accuracy. Precision does not always mean uniformity. It means appropriateness. In these contexts, accuracy emerges from selective attention. Only the faces that meet are fully worked. Hidden surfaces remain rough, saving effort while increasing friction where it benefits stability. This selectivity indicates planning guided by experience rather than rigid design. Templates may have played a role in transferring form. A wooden or clay guide pressed against one stone could capture its shape and transfer it to another. The guide would wear down or break, but the stone would retain the accuracy. Once the stone was set, the template's purpose ended. Wood decays. Clay erodes. The stone remains without revealing how its form was communicated. This method requires no measurement beyond the ability to match shapes. It relies on touch and sight, senses honed through repetition. Rope appears repeatedly as both measuring and guiding tool. Egyptian reliefs show surveyors using knotted cords to lay out foundations. A rope with evenly spaced knots allows distance to be counted through touch alone. When stretched, it reveals deviation immediately. A sag indicates imbalance. A twist signals misalignment. Rope transmits information directly to the hands. Its flexibility is an advantage, not a flaw. The cubit rod, often cited as an early standard, reinforces this emphasis on consistency rather than abstraction. Based on the length of the forearm, it ties measurement to the human body. Surviving examples show careful subdivision, yet the true power of the cubit lies in its repeatability. A structure built entirely with one reference unit remains coherent even if the unit differs slightly from another culture's standard. Uniformity within a system matters more than universality across systems. Leveling large surfaces posed greater challenges. Courtyards and temple floors extend beyond the reach of a single rod. Here, water likely served as the ultimate arbiter. A channel filled with water establishes a plane that ignores distance. Builders could compare heights across space by referencing the same liquid surface. This method requires vigilance. Evaporation, spillage, and uneven channels introduce error. Yet, when monitored carefully, water remains the most honest of levels. Drainage provides evidence of such care. Many ancient floors slope subtly to direct water away, a gradient too slight to be accidental. Water flows where intended, not where gravity might choose if left unchecked. This control suggests repeated checking and correction during construction. The slope is not imposed abruptly. It emerges gradually through adjustment. Urban planning amplifies these principles. At Teotihuacan, the city grid follows a consistent orientation slightly offset from true north. The deviation is not random. It is applied uniformly across the city, indicating a chosen reference that governed expansion over time. Once established, the orientation was maintained through replication rather than recalculation. each new structure aligned itself to the existing grid, preserving coherence. In Mesopotamia, where mud brick dominated, stone foundations still exhibit careful leveling. Ziggurats rise in stepped platforms, each supporting the next. A slight error at the base would compound dangerously upward. The survival of these structures indicates that early errors were caught and corrected. Clay tablets record labor and materials, but remain silent on technique. Measurement knowledge was considered ordinary, not worthy of inscription. This ordinariness explains its invisibility. Ancient builders did not celebrate accuracy as an abstract achievement. It was simply expected. Precision was a means to an end, not a message. When it succeeded, it went unnoticed. When it failed, structures cracked or collapsed and were repaired or abandoned. Stone preserves success more readily than failure. Modern archaeology often seeks metal instruments as proof of measurement. Their absence is interpreted as absence of method. Yet most ancient measuring tools were organic. Wood, rope, leather, and water do not fossilize easily. Their disappearance leaves a misleading gap. The stone alone remains, bearing the outcome without the process. Measurement also lived in the body. A trained worker develops an internal sense of distance through repetition. Steps become uniform. Arm spans repeat reliably. Sight lines align instinctively. When many workers share the same training, results converge. This embodied measurement leaves no artifact. It exists only in practice. Rejected stones at quarries provide indirect evidence of this discipline. Blocks abandoned mid-shaping reveal attempts that went wrong. A crack wandered unpredictably. A face failed to align. These stones were left behind, not forced into use. Selection occurred early. Only stones that behaved as expected were transported. This filtering increased overall precision at the building site. The cumulative effect of these practices is coherence across scale. From the fit of a single joint to the alignment of an entire city, the same principles apply: reference, repetition, correction. Measurement was not a separate phase. It was continuous, embedded in every action. The absence of formal documentation does not signal ignorance. It signals integration. When later societies encountered these results without the supporting practices, the methods appeared mysterious. Precision seemed to exceed available tools. The illusion arises from forgetting that time, discipline, and feedback are themselves powerful instruments. Stone remembers their application even when the instruments themselves have vanished. Weight was never the true enemy of ancient builders. Instability was. A stone resting fully on the ground behaves honestly. Its mass presses downward, predictable and constant. Lift that same stone into the air, and uncertainty multiplies. Ancient transport methods reflect a deep preference for contact, balance, and gradual change. The goal was never to conquer gravity, but to guide it. Reliefs from the Middle Kingdom in Egypt show colossal statues placed on wooden sledges, dragged across prepared ground by coordinated teams. One figure pours liquid in front of the runners, an action long dismissed as symbolic until modern physics demonstrated its effect. Damp sand stiffens, preventing grains from piling up and reducing friction dramatically. The stone moves not because strength overwhelms resistance, but because resistance is quietly diminished. This solution required observation, not theory. Once discovered, it could be repeated anywhere sand and water were available. Sliding offers advantages that rolling does not. Rollers concentrate weight at small contact points, increasing the risk of crushing and slippage, especially on slopes or uneven terrain. Sliding distributes load evenly. The center of gravity remains low. Control improves. Ancient builders appear to have favored this predictability. Where the ground was rough, it was shaped gradually, not paved, but leveled enough to behave consistently under load. Transport began at the quarry. Stones were often shaped close to their final dimensions before movement. Excess material was removed early, reducing weight and lowering risk. At Aswan, abandoned granite blocks reveal this calculation. Some were left unfinished because cracks appeared, or weight reduction proved insufficient for safe transport. These stones were not forced onward. They were rejected. This restraint speaks to an understanding of limits rather than a desire to test them recklessly. Leverage played a central role in overcoming those limits. A long wooden beam can raise a massive block by a few centimeters. A wedge placed beneath holds the gain. The beam is moved, and the process repeats. Increment by increment, a stone can be elevated, aligned, or redirected without ever leaving control. The wedges were often wood or stone. The beams decayed. The method left little behind once complete. Earth itself became a tool. Temporary ramps built from soil, rubble, and debris extended the ground to wherever it was needed. These ramps supported immense loads because Earth distributes weight broadly. Once a stone reached its position, the ramp was dismantled and reused. What remains is the platform, not the path. In many ancient sites, surrounding terrain shows subtle disturbances consistent with such temporary works, though centuries of erosion blur their outlines. At Baalbek, where individual stones weigh hundreds of tons, the quarry sits slightly uphill from the platform. Gravity assists movement rather than opposing it. Stones may have been slid downhill under control, then nudged forward with levers and packed earth. The final placement required precision, but the approach relied on balance rather than brute force. The terrain itself participated in the solution. Time was deliberately stretched. A stone might move only a few meters in a day. This pace allowed constant inspection. If a rope frayed, it was replaced. If the ground shifted, it was corrected. If a crack appeared, movement stopped. There was no advantage to speed. Damage incurred during haste could not be undone. Patience preserved both stone and labor. Ropes were critical to this system. Ancient ropes made from flax, papyrus, palm fiber, or animal hide can support tremendous loads when braided correctly. Multiple ropes shared tension, creating redundancy. If one failed, others held. Rope also transmitted information. Changes in tension could be felt instantly, warning of imbalance or obstruction. The hands became sensors. Coordination amplified effectiveness. Many workers pulling together, synchronized by rhythm or chant, generate steady force without sudden spikes. This reduces peak strain and fatigue. Such practices survive in traditional labor today, not because they are ceremonial, but because they work. The human voice becomes a regulating tool, aligning effort across bodies. Water transport expanded possibilities further. A stone floating on water effectively weighs nothing. Egyptian quarries near the Nile exploited seasonal floods, moving blocks when water reached closer to quarry faces. Simple rafts built from logs or bundled reeds provided buoyancy. Stability depended on width rather than depth. Stones were secured with ropes that allowed flex rather than rigid fastening. The system adapted to waves instead of resisting them. Loading and unloading posed their own challenges. Balance, not lifting, provided solutions. A stone could be tipped gradually onto a raft using leverage and counterweight. Unloading reversed the process. Gravity assisted both operations when managed carefully. Harbors in the ancient Mediterranean show cut channels and mooring points sized for heavy cargo, suggesting routine handling of massive stone by water. In mountainous regions like the Andes, where rivers were less navigable, builders turned to terrain. Stones were quarried uphill from construction sites whenever possible. Controlled descent replaced hauling. Paths followed contours, reducing slope. Switchbacks lengthened distance to lower gradient. Ropes restrained movement. The stone moved when allowed and stopped when required. Turning stones required finesse. Rotation increases friction and destabilizes load. Builders solved this by rocking stones onto pivot points. A rounded stone or wooden block placed beneath a corner allowed rotation with minimal force. Once aligned, the pivot was removed. Some stones retain small protrusions that may have served as temporary grip points during transport. After placement, these were trimmed away, erasing their function. Transport and placement were not separate phases. Stones were often tested at the site, removed, adjusted, and returned. Final fitting occurred where gravity would confirm success. This overlap reduced error. A stone that fit at the quarry might behave differently after transport. The builders allowed for this by keeping adjustment possible until the last moment. Modern reconstructions often struggle because they compress timelines. When attempts are made to move stones quickly with limited labor, difficulty appears overwhelming. When time pressure is removed, simpler methods succeed. The ancient system was designed for endurance, not spectacle. It accepted slow progress as the cost of safety and accuracy. The absence of wheels in many ancient contexts reflects practicality. Wheels perform best on prepared roads and distribute weight poorly under extreme loads. Sliding adapts better to rough ground and variable surfaces. The choice was environmental, not technological. Ancient builders selected methods that matched their terrain rather than forcing terrain to match their tools. What remains today are stones positioned where modern machinery would struggle to place them delicately. The methods that delivered them left few traces because they were temporary by design. Ramps were dismantled, ropes decayed, wooden sledges rotted. Only the stone endured. The movement of massive stone without machines appears miraculous only when imagined as a single act. In reality, it was a chain of small, controlled decisions repeated over long periods. Balance replaced force. Patience replaced power. Gravity became collaborator rather than adversary. The stones arrived not through triumph, but through restraint, guided every step by a system that valued control over speed. Stone does not always yield when struck. Often, it responds more predictably when encouraged to separate along paths it already prefers. Ancient quarrying practices reveal an understanding of this behavior that relied less on cutting and more on guiding fracture. Instead of removing material grain by grain, builders learned to persuade stone to part where its internal structure was already inclined to break. One of the oldest techniques used for this purpose is fire setting. A fire built directly against exposed rock heats the surface slowly. Stone expands when warmed, but not evenly. Once sufficient heat has penetrated, water is poured over the surface. The sudden cooling creates thermal shock, internal stresses increase, and cracks form along natural weaknesses. Repeated cycles deepen these fractures. Archaeological traces of this method appear in prehistoric mines across Europe, Africa, and the Near East, where reddened stone surfaces and charcoal layers remain embedded in quarry walls. Fire setting does not produce smooth finishes, it creates controlled breakage. For quarrying, this is enough. Large blocks can be detached without blades. Final shaping occurs later. The method requires attention to timing. Heat applied too quickly can shatter stone unpredictably. Applied patiently, it encourages separation along desired lines. Skill lies in pacing rather than intensity. Ancient writers treated this knowledge as ordinary. Pliny the Elder, writing in the 1st century, described stones split by heating and sudden cooling, noting the effect without framing it as innovation. His tone suggests familiarity rather than wonder. The absence of detailed explanation implies that the method was widely understood and required no elaboration. Wooden wedges offered another path to fracture. Narrow grooves cut or scored into stone except rows of wooden pegs. When soaked with water, the wood absorbs moisture and expands. The pressure builds slowly and evenly. Stone yields along the line of wedges, splitting cleanly. This technique appears across cultures and centuries, from ancient China to Japan and Europe. The resulting stone faces are flat and predictable. The grooves left by wedge placement are sometimes still visible in ancient quarries. They appear as evenly spaced linear depressions, evidence of deliberate planning rather than random impact. The method demands patience. The split may take hours or days to complete. Once it does, the result is irreversible. The stone separates where intended or not at all. Moisture itself can act as a tool. In colder climates, water entering cracks freezes and expands over seasonal cycles. This natural process widens fractures. Quarry workers could guide it by scoring surfaces and allowing time to do the rest. While slow, the method requires little effort beyond planning. Stone responds to cycles it cannot resist. Heat and moisture interact in subtle ways. A heated stone vibrates differently than a cold one. Expansion alters internal stress patterns. Cooling locks fractures into place. These interactions were learned through observation rather than theory. Ancient builders had time to notice how stone behaved under repeated exposure to fire, water, and air. Sound enters this discussion quietly. Modern experiments show that vibration can alter material behavior. Low-frequency vibration causes granular materials to flow. High-frequency vibration assists cutting in modern ultrasonic tools. There is no evidence that ancient cultures possessed powered vibrational devices. There is evidence that they understood resonance. Architectural spaces from antiquity often emphasize acoustics. Certain chambers amplify sound in unusual ways. Narrow passages transmit tones across distance. The purpose is debated, often framed as ritual. Yet practical experimentation may have accompanied ceremonial use. A stone struck rhythmically responds differently than one struck randomly. Repeated impacts at the right interval can propagate cracks along existing weaknesses. Some ancient fractures appear unusually straight, lacking the chaotic edges typical of forceful impact. Whether sound played a role remains unproven. What matters is that ancient builders explored stone behavior beyond simple striking. They observed how repeated, controlled actions produced different outcomes than sudden force. chemical interaction is sometimes proposed. Certain plant extracts produce mild acids capable of etching limestone. Legends from the Andes describe stones softened by plant juices. Spanish chroniclers recorded these stories without understanding their basis. Limestone reacts to weak acids over time. Granite resists most organic acids. The legends may preserve metaphor rather than method, or memory of techniques applied selectively to softer stone. Experiments show that oxalic acid, present in many plants, can etch limestone slightly. Applied repeatedly with abrasion, it could aid surface shaping. The effect is slow and subtle. It leaves little trace once rinsed. If used, such methods would be nearly invisible archaeologically. What is clear is that ancient builders did not rely on a single technique. Heat, moisture, pressure, abrasion, and impact worked together. A stone might be heated, wedged, soaked, and struck over days. The final form reflects the sequence rather than any one action. The process favored correction. If a crack wandered, heat could be reapplied elsewhere. Wedges could be repositioned. The stone responded gradually. The quarry face preserves this dialogue more clearly than finished monuments. At Aswan, the unfinished obelisk cracked along a natural fault. The builders abandoned it immediately. The decision reveals respect for stone behavior. Forcing the issue risked collapse. The stone dictated the outcome. Thermal shock may also have been used for smaller-scale shaping. Heating a narrow line and cooling it can create a groove. Repeated cycles deepen the channel. The resulting profile differs from chisel marks. Some ancient grooves match this texture. Fire leaves soot and discoloration, but weathering can erase these traces over centuries. Sound-based methods, if used, leave almost no trace at all. Vibration does not fossilize. If resonance assisted fracture, the stone would not record the cause, only the result. This invisibility complicates verification. Archaeology favors visible evidence. Methods that rely on air, heat, or water are easily overlooked. Ancient practice likely layered methods rather than isolating them. Modern reconstructions often test a single technique in isolation and judge it insufficient. Ancient builders combined approaches, allowing each to compensate for the limits of the others. Time linked them together. Slowness allowed feedback to guide adjustment. The pace of this work shaped its aesthetics. Stone split by fracture carries broad, planar surfaces. Curves emerge where abrasion dominates. Sharp corners are rare and often softened intentionally to reduce stress. Recognizing these patterns helps distinguish methods without invoking hidden technology. The ancient science of stone did not separate physics from craft. Knowledge lived in hands, ears, and eyes. It adapted to local material and climate. Limestone behaves differently than granite. Basalt fractures unpredictably. Techniques adjusted accordingly. When a method failed, it was abandoned. When it worked, it was repeated until it became invisible. Heat fades, sound dissipates, water dries. The stone remains, shaped by processes that left little behind. The absence of blades does not imply absence of understanding. It suggests that understanding took forms that were never meant to endure beyond the work itself. The stone stands as the final record of a conversation between material and patience. Smooth stone invites a false conclusion. Modern eyes associate polish with speed, blades, and motors. In ancient contexts, smoothness more often signals repetition. Abrasion removes material not by force, but by persistence, distributing pressure across time until resistance yields evenly. The result hides the labor that produced it. No sharp scars announce impact. The surface appears settled, as if it arrived at its final form gradually rather than through decisive blows. Abrasion begins with a simple relationship. A harder or equally hard material rubs against stone with an intermediate grit. Sand, crushed quartz, or powdered stone itself becomes the active agent. The holder of the grit may be soft wood, leather, bone, or even copper. The holder guides motion. The grit performs the work. This separation of roles explains why tools made from seemingly inadequate materials could still shape hard stone effectively. In regions rich in quartz sand, such as Egypt, the conditions favored this approach naturally. Quartz ranks high in hardness and readily abrades granite when motion and pressure are applied consistently. Copper alone cannot cut granite efficiently. Copper combined with abrasive becomes part of a composite system. As the copper wears, it continually exposes fresh grit. Tool wear becomes an advantage rather than a limitation. The surfaces produced by abrasion carry distinctive traits. Channels have rounded bottoms rather than sharp internal corners. Width remains consistent across length. Depth progresses evenly. These features appear in ancient drill holes and grooves carved into hard stone. Spiral markings sometimes appear, not as evidence of rapid rotation, but as a record of steady advance under constant motion. Speed was unnecessary. Control mattered more. Polishing extends abrasion beyond shaping. Once a surface is flattened, finer grit replaces coarse particles. Scratches left by larger grains are reduced gradually. Repeating this sequence produces reflective finishes. Diorite statues from ancient Egypt demonstrate this clearly. Diorite is extremely hard, yet these surfaces gleam with uniformity. The polish implies extended finishing over weeks or months. The decision to invest such time reflects cultural priorities rather than technological excess. In many sites, smoothing is selective. Only faces that meet are worked extensively. Hidden surfaces remain rough. This choice increases efficiency and stability. Roughness improves friction where stones rest against one another. Smoothness is reserved for contact planes and visible faces. The contrast reveals intention. Effort was applied where it mattered most. Curved surfaces pose a particular challenge for abrasion. Abrasion naturally flattens. To create curves, pressure and motion must vary deliberately. Flexible pads, rounded stones, or shaped wooden forms guide the abrasive. The grit conforms to the guide rather than imposing a flat plane. Over time, curvature emerges through repeated checking and correction. Ancient bowls, basins, and vessels carved from stone show symmetrical curves difficult to achieve with chisels alone. Water plays a supporting role throughout this process. Wet abrasion reduces dust and carries away debris. It cools the surface, preventing thermal stress. In some cases, slurry forms, enhancing cutting efficiency as particles circulate between surfaces. The mixture of water and grit becomes a working medium rather than a passive byproduct. Experiments replicating these conditions show measurable material removal even from granite. The absence of clear tool marks on many ancient stones is itself evidence. Chisels leave impact scars. Abrasion blends marks into the surface. Many ancient stones show uniform texture interrupted only by natural inclusions. The stone appears calm rather than wounded. This aesthetic aligns with a process that values even pressure over decisive strikes. Joint surfaces deserve special attention. At sites with tight-fitting stonework, contact faces are often smooth and slightly convex. Each stone meets its neighbor across a broad area. Achieving this fit requires repeated testing. A stone is pressed against another. High points reveal themselves through contact. Material is removed only where needed. The stone returns to position. The cycle repeats until the fit is complete. This feedback loop reduces error naturally. Measurement is implicit. The stone itself indicates where correction is required. No abstract geometry is necessary. Touch and sight guide adjustment. The final joint reflects accumulated refinement rather than a single precise cut. The process is slow but reliable. Polishing was not always the final step. Some surfaces were left intentionally rough. Structural considerations guided this choice. Smooth surfaces slide. Rough surfaces grip. In dry stacked construction, friction contributes to stability. Ancient builders understood this intuitively. Finish was applied selectively to balance movement and resistance. Abrasive tools were often perishable. Wooden boards held grit for polishing large surfaces. Leather pads conformed to curves. Woven fibers distributed abrasive evenly. Once worn, these tools were discarded. No trace remains unless preserved by exceptional conditions. Stone tools also served as abrasives. Harder stones rubbed against softer ones. Local geology dictated selection. The concept of a blade assumes cutting through concentration of force. Abrasion distributes force over area and time. This reduces tool wear and risk of cracking. For hard stone, the approach is safer. Precision emerges gradually. A surface checked repeatedly against light, water, or neighboring stone reveals irregularities. These are removed incrementally. Visual feedback played a critical role. Reflections reveal flatness. Distortion signals curvature. Ancient mirrors and lenses made from polished stone or metal demonstrate sensitivity to surface behavior. The human eye served as an instrument. The hand followed what the eye perceived. This integration reduced reliance on external gauges. Drilling follows the same logic. A rotating shaft with abrasive at the tip bores into stone. The shaft does not need to be hard. The grit does the cutting. Pressure and motion are adjusted to prevent binding. The resulting holes show smooth walls and spiral wear patterns consistent with steady advancement. High-speed rotation is unnecessary. Consistency suffices. The aesthetic that emerges from abrasion differs from that of impact. Edges are softened. Corners are rounded unless intentionally sharpened. The stone appears settled rather than forced. Modern expectations often favor visible tool marks as proof of work. Ancient practice favored disappearance of process. The finished surface concealed labor rather than advertising it. This concealment contributes to misunderstanding. Without visible scars, modern observers assume missing tools. In reality, the tools were indirect. Sand leaves no signature. Water erases itself. Wood decays. The stone remains without its supporting system. What survives is the result, stripped of its means. Abrasion rewards patience. It allows correction at every stage. If an error appears, it can be reduced gradually. There is no catastrophic failure as with brittle fracture. This safety makes it suitable for valuable stone. Time replaces power. Repetition replaces speed. The knowledge required is experiential. It accumulates through doing. Pressure, rhythm, and duration are learned through practice. When blades are absent, hands adapt. Stone yields not to force, but to persistence. Its surface records that persistence in smoothness. Understanding this process dissolves much of the mystery surrounding ancient stone finishes. No hidden machines are required. No lost materials need to be invoked. The quiet science of abrasion, applied patiently across years, accounts for surfaces that still challenge modern assumptions. The stone stands smooth not because it was conquered quickly, but because it was persuaded slowly. Precision. Across ancient civilizations often appears so consistent that it tempts the imagination toward hidden networks, lost global sciences, or forgotten empires. Stone walls in Egypt, Peru, India, and the Mediterranean seem to answer the same engineering problems in similar ways, despite vast separation in time and geography. The similarity, however, does not require shared origin. It requires shared constraint. Stone behaves the same everywhere, and human bodies respond to it in comparable ways when faced with the same limits. Hard stone resists sudden force, regardless of culture. Gravity pulls downward in every climate. Water seeks level, whether poured in the Nile Valley or the Andes. When builders confront these constants without modern machinery, certain solutions naturally repeat. Sliding proves safer than lifting. Abrasion proves more reliable than cutting. Repetition proves more accurate than haste. These principles do not belong to a civilization. They belong to material reality. At the Giza Plateau, limestone casing stones were set with joints so tight that light barely penetrates them. In Cusco, polygonal stones interlock with no mortar, their seams resisting seismic movement. At first glance, these results appear identical. Closer inspection reveals meaningful differences. Egyptian joints favor straight planes and consistent thickness. Inca joints favor curved contact surfaces that dissipate stress. The goal is shared, stability, but the execution responds to environment. Seismic activity shaped Andean priorities. Stones that could move slightly and settle back into place survived earthquakes. Flat, rigid joints would have failed. Egyptian monuments faced different threats. Stability against gravity and time mattered more than flexibility. Precision was adapted to context, not copied blindly. This distinction undermines claims of a single lost technique while reinforcing the role of observation. In the Indus Valley, stone platforms and drainage channels show careful leveling across long distances. Fired brick dominated visible construction, yet stone foundations beneath were precise. Water flowed where intended. Slopes were subtle and consistent. This suggests that measurement knowledge was widespread and practical, not reserved for monumental stone alone. Builders applied it wherever failure would have consequences. At Teotihuacan, the city grid follows a fixed orientation slightly offset from true north. The angle repeats across kilometers. The deviation is not error, it is choice. Once established, the reference governed expansion through replication rather than recalculation. Each new structure aligned itself to what already existed. Coherence emerged from continuity. Ancient Greek temples introduce another refinement. Columns taper, platforms curve upward slightly at the center. These adjustments counter optical illusion, making structures appear straight to the human eye. Achieving this effect requires planning and careful execution. The stone is intentionally shaped away from geometric purity to achieve visual balance. Precision here is perceptual rather than mathematical. These examples reveal a shared principle. Accuracy is not uniformity, it is suitability. Builders adjusted methods to purpose. A fortress wall values interlock and mass. A temple values symmetry and harmony. A canal values slope and continuity. Stone was shaped according to function rather than ideology. Claims of a lost global science often overlook time. Ancient projects unfolded over decades, sometimes generations. A pyramid or terrace system was not rushed. Adjustments were made gradually. Errors were corrected early before weight magnified their effect. Modern construction compresses timelines, replacing patience with machinery. When time is removed from interpretation, difficulty appears exaggerated. Parallel development explains convergence without invoking contact. Sliding heavy blocks is safer than lifting them anywhere. Abrasion works on hard stone everywhere. Water levels surfaces in every climate. These are not cultural secrets. They are physical truths. Independent discovery under shared constraints is expected. Where contact did occur, it left different traces. Decorative motifs migrated, measurement units shifted, tool forms evolved. In stoneworking technique, however, diffusion appears limited. Local methods dominate. This suggests that most precision arose independently through practice rather than inheritance. The idea of a single lost technique also assumes complexity where simplicity suffices. The methods inferred from stone are not advanced in the modern sense. They are reliable. They demand attention rather than invention. They favor control over force. This does not diminish ancient achievement. It clarifies it. Maintaining accuracy over years without standardized instruments demands discipline. Passing that discipline across generations demands social continuity. Precision is a social product as much as a technical one. When continuity breaks, precision declines. Later repairs at ancient sites often reveal this decline clearly. Stones are smaller. Joints widen. Surfaces lose refinement. The change reflects loss of practice knowledge, not loss of intelligence. Roman concrete altered priorities. Stone fitting became less critical where poured material could fill gaps. Some older techniques faded through disuse. When stone precision returned in later periods, it was relearned slowly through practice rather than recovered from texts. In Europe, medieval masons rebuilt stone knowledge over centuries. Some principles were rediscovered, others were approximated. The result differed subtly from earlier work. The stone records these shifts. Comparative modern analysis reinforces this view. Laser scans reveal flatness and curvature in ancient structures. GPS confirms alignment. These tools do not replace ancient methods. They measure them again. The results show that precision existed, but varied by context. Ancient builders optimized for permanence and stability. Modern builders optimize for speed, cost, and modularity. Different goals produce different techniques. Precision across civilizations does not require hidden machines. It requires shared material limits and human persistence. When knowledge failed, it did not vanish instantly. It thinned, first in places where it mattered least, then where it once defined identity. The archaeological record captures this through gradual change rather than sudden absence. Stone, durable and unforgiving, preserves this story with clarity. Understanding this pattern dissolves the illusion of lost technology. What was lost was not science, but continuity. What appears impossible today often reflects unfamiliar priorities rather than missing capability. Stone teaches the same lessons everywhere. Those who listen long enough arrive at similar answers. The similarities across civilizations invite curiosity, but also restraint. Not every match implies contact. Sometimes stone simply instructs patiently, repeating its rules to anyone willing to work within them. The quiet convergence of ancient methods is not evidence of mystery. It is evidence of persistence applied under the same unyielding laws of material and gravity. When ancient stone structures appear to surpass the capabilities of the cultures that followed them, the gap is often explained as mystery. Something must have been lost. Some hidden knowledge, some forgotten technology, some interruption so severe that later builders could only imitate imperfectly. Yet the stone itself suggests a quieter process. What failed was not intelligence or ingenuity, but continuity. Skill did not vanish in a moment. It thinned. At many long-occupied sites, stonework quality changes gradually rather than abruptly. Early phases display careful fitting, deliberate surface treatment, and confident handling of large blocks. Later additions rely on smaller stones, wider joints, and increasing use of filler materials. The transition is rarely acknowledged in texts. It appears only in the stone, where precision relaxes and tolerance widens. This pattern repeats across regions and centuries. In Egypt, the shift is visible at the Giza Plateau. The casing stones of the 4th Dynasty pyramids show extraordinary flatness and alignment. Later temples, built under dynasties with equal or greater resources, rarely match this level of precision. The builders still knew how to quarry, transport, and erect stone. What changed was the investment in refinement. Mortar became acceptable. Speed mattered more. The older discipline no longer defined success. Political and social disruption accelerates this thinning. Long-term apprenticeship systems depend on stability. Skilled lineages require patronage, predictable labor organization, and uninterrupted transmission. When dynasties fall, administrations reorganize, or religious priorities shift. These systems fracture. Knowledge that lives only in practice has no archive to retreat into. It dissolves with the people who carried it. The Andes offer a similar story. Inca stonework represents a peak of dry-fit construction adapted to seismic terrain. After conquest, colonial builders reused Inca foundations but did not continue the methods that produced them. Brick, adobe, and mortar-based masonry replaced slow-fitting stone. The choice was pragmatic. The older precision demanded time and specialized training that no longer served immediate goals. Within generations, the practice faded. Loss does not occur evenly. Some skills persist longer than others. Measurement may survive while fitting declines. Transport methods may continue while surface finishing deteriorates. This selective erosion creates hybrid structures that confuse later observers. The work appears inconsistent, as if knowledge were applied partially or incorrectly. In reality, builders worked with what remained accessible to them. Environmental change contributes quietly. Quarrying depends on access. Transport depends on terrain. Floods, landslides, earthquakes, or deforestation alter conditions. When preferred stone sources become difficult to reach, builders adapt by using smaller or inferior material. Technique changes in response. At Angkor, early temples use finely cut sandstone. Later structures rely more on laterite, a softer and irregular stone that demands different handling. Precision declines not from ignorance, but from altered circumstance. Roman construction illustrates another form of loss through substitution rather than disruption. Roman builders mastered concrete, arches, and vaults. Stone fitting remained important, but its role shifted. Perfect joints were no longer essential when poured material could fill gaps. Some stone techniques were retained, others neglected. When the Roman system collapsed, concrete knowledge faded in parts of Europe. Stone construction continued, but without the same integrated understanding. Medieval builders relearned stone skills gradually. Trial replaced inheritance. Guild systems eventually stabilized practice, but the results differed subtly from ancient work. Chisel marks became more visible. Mortar compensated for irregularity. The stone reveals this transition clearly. Precision returns, but through a different path, shaped by new priorities. Modern restoration efforts highlight how fragile this knowledge remains. Attempts to repair ancient structures often introduce errors. Replacement stones are cut flat where originals were subtly curved. Mortar fills joints that were once dry fit. The intent is preservation, but the method alters structural behavior. The difference exposes how much ancient skill resided in adjustment rather than specification. Failure at the quarry provides another window into this process. Abandoned stones show attempts that went wrong. Cracks wandered, surfaces misaligned. These blocks were left behind, not forced into use. Such restraint reflects confidence. Builders knew when to stop. These lessons were learned through experience and passed on through demonstration. When transmission broke, caution often increased. Later builders avoided risk by choosing simpler methods. This pattern challenges the notion of a lost golden age followed by ignorance. What emerges instead is a shifting balance of priorities. Precision demands time. Time demands stability. When stability weakens, precision becomes costly. Societies adapt. They choose speed, flexibility, or scale over refinement. The stone records that choice silently. The temptation to imagine vanished machines arises because the results remain while the practices disappear. Later observers see outcomes without context. The absence of visible tools suggests absence of method. In reality, the methods were never meant to endure. They relied on wood, rope, water, sand, and habit. These elements return to the environment quickly once work ends. What remains is stone exceeding the expectations of those who encounter it later. This gap invites wonder. It also invites error. The assumption that complexity must explain precision overlooks the power of repetition. Ancient builders did not rely on secret devices. They relied on continuity. When continuity broke, the skill thinned until the stone began to appear miraculous. Understanding this thinning reframes the past. Ancient builders were not uniquely gifted. They were consistently trained. Their advantage lay in sustained attention applied across generations. When that attention ceased, the results could not be replicated easily. The stone endured. The practice did not. The lesson is not about what was lost, but about what was required to maintain it. Precision is fragile. It depends on social structures as much as technical insight. When those structures erode, stone still rises, but with less confidence. Joints widen, surfaces roughen. The change is quiet, but unmistakable. Stone preserves this story with unusual clarity. It shows not only what humans achieved, but what they gradually set aside. The disappearance of method does not erase the result. it magnifies it. What once was ordinary becomes extraordinary when forgotten. The stone stands unchanged, waiting for its silence to be misread as mystery, when it is simply the record of continuity broken slowly over time. The modern idea of a tool is narrow. It favors objects that can be held, catalogued, and displayed. Blades, drills, machines, instruments with edges and motors dominate the imagination. When these are absent, explanation falters. Ancient stonework exposes the limits of this definition. The tools that mattered most were not always discrete objects. They were systems, assembled temporarily from material, environment, and human behavior, then allowed to disappear once their purpose was fulfilled. Stonework began before contact. The choice of quarry determined everything that followed. Ancient builders did not select stone solely for proximity. They observed grain, fracture patterns, bedding planes, and weathering behavior. A stone that split predictably reduced labor before it began. The quarry face itself became the first tool. Natural planes guided separation. Pressure followed structure rather than opposing it. The stone's internal order did much of the work. Water functioned as more than a resource. It acted as an instrument of measurement, transport, lubrication, and abrasion. A shallow trench filled with water established level across distance without calculation. Wet sand reduced friction beneath sledges. Slurry carried abrasive particles during polishing. In each case, water replaced a mechanical component. It provided consistency where solid instruments would have required precision manufacturing. Gravity was not resisted. It was recruited. Stones were slid downhill whenever possible. Elevation was achieved gradually, layer by layer, rather than through dramatic lifts. Large structures rose as working surfaces rose with them. The Great Pyramid did not require stones to be hoisted to full height in a single motion. Each course established a new ground. Gravity confirmed placement. A stone that settled correctly remained stable. One that did not reveal its error immediately. Time itself functioned as a tool. Processes that appear inefficient by modern standards become effective when time is abundant. Fire setting relies on slow heating. Wooden wedges require hours or days to expand. Abrasion demands repetition. None of these methods succeed quickly. All succeed eventually. Time replaced power. The longer the duration, the less force was required at any moment. Risk diminished accordingly. Sand, often overlooked, was central. Quartz-rich sand abrades granite. Finer sand polishes limestone. Mixed with water, sand becomes a cutting medium. Held in place by wood, leather, or soft metal, it transforms weak materials into effective tools. The abrasive was the active agent. The holder merely guided motion. This reverses modern assumptions about durability. The tool sacrificed itself, so the stone could be shaped gently. Copper regains relevance under this lens. Copper alone dulls quickly against hard stone. Copper combined with abrasive becomes part of a composite system. Its softness allows grit to embed and renew continuously. Tool wear becomes functional. The absence of hardened steel does not limit capability. It changes strategy. Control replaces speed. Heat extended this system. Fire setting exploited thermal expansion. The fire was not a tool in isolation. It worked with stone structure and water. Sequence mattered. Slow heating encouraged separation. Rapid cooling locked fractures in place. Skill lay in pacing rather than intensity. Heat prepared stone for other actions. It did not act alone. Wood played multiple roles beyond wedges and levers. Wooden frames guided shape, templates transferred form, flexible supports aided curvature. Once the stone was finished, the wood decayed. The result remained. The tool vanished. Rope extended human force and perception. It measured distance, defined straight lines, distributed load, and communicated tension through touch. A twisted rope revealed misalignment immediately. The body felt error before it was seen. Sound acted as feedback. A stone struck lightly rings differently depending on internal cracks. Quarry workers learned to listen. A dull tone warns of weakness. A clear ring suggests integrity. The ear became an instrument. This sensory feedback guided selection and placement. No inscription records it. The knowledge lived in practice. The human body itself was a calibrated tool. Steps measured distance. Arm spans defined width. Sight lines aligned blocks. Repeated motion refined judgment. Experienced workers reproduced angles and pressures consistently without external gauges. Precision emerged through habit. This embodied approach explains why complex devices were unnecessary. When body, environment, and material form a single system, instrumentation disperses across the process. Social organization also functioned as a tool. Coordinated labor reduced strain. Shared rhythm synchronized effort. Knowledge of when to stop prevented failure. Songs or chants regulated pulling. Seasonal labor schedules aligned construction with agricultural cycles. These systems amplified capability without altering material reality. They shaped how force was applied and controlled. Modern reconstructions often fail because they isolate elements. A copper chisel is tested without abrasive. Stones are lifted rather than slid. Timelines are compressed. Experiments answer different questions than ancient builders asked. Ancient builders asked how stone could be persuaded to move, split, or settle safely. Modern builders ask how to force outcomes efficiently. The difference in mindset produces different interpretations of feasibility. Redefining the tool dissolves the need for lost advanced technology. A quarry face is a tool. A slope is a tool. A season is a tool. Even patience becomes instrumental. These elements do not fossilize. They leave no museum artifacts. Their absence from the record is expected, not suspicious. Written sources reinforce misunderstanding. Ancient texts rarely catalog tools. They describe outcomes. A temple is completed. A statue is erected. The means are assumed. Tool inventories mattered less than results. When later societies encountered these stones without the surrounding systems, the work appeared miraculous. The tools they expected to find were gone because they were never meant to last. Understanding ancient stonework requires abandoning the search for singular devices. The technology was distributed. It existed in relationships rather than objects. When those relationships ended, the technology faded without leaving debris. What remained was stone shaped by systems that dissolved back into the environment. This perspective reframes the question entirely. Stone was not manipulated without tools. It was shaped by tools that modern definitions refuse to recognize. They were quieter, slower, and temporary. They depended on attention rather than power. When those tools are acknowledged, the mystery recedes. The ancient world did not hide machines from the future. It practiced methods suited to its conditions. Those methods required continuity to survive. When continuity ended, the practices disappeared. Stone remains as the final witness, shaped by tools that were never meant to be seen, only used. The idea that ancient builders possessed a secret science lost to time gains its power from absence. The methods are gone. The structures remain. Between them, imagination rushes to fill the gap. Yet absence alone does not imply disappearance. Many things vanish because they were never designed to endure. Stone survives precisely because it resists change. The systems that shaped it were meant to dissolve once their work was complete. Modern observers often begin with a flawed comparison. The best surviving ancient work is set against average modern construction. The contrast feels extreme. When the comparison is reversed, when ancient stone is measured against modern craft work allowed sufficient time, the gap narrows. Precision is not exclusive to a period. It is a function of priority. Ancient builders optimized for permanence. Modern systems optimize for speed, cost, and standardization. Different goals produce different outcomes. Time is the missing variable in most interpretations. Ancient projects unfolded slowly. A pyramid, terrace system, or temple complex might span decades or generations. Adjustments were made incrementally. Errors were corrected before weight amplified them. Modern experiments often fail because they attempt to compress this timeline into days or weeks. Under pressure, simple methods appear inadequate. Remove urgency, and they succeed quietly. Another illusion arises from scale. A single stone weighing dozens of tons appears unmanageable when imagined as a discrete problem. In practice, it was addressed through a sequence of small, controlled actions. Each movement was modest, each adjustment reversible. Over weeks, progress accumulated. The stone arrived where it needed to be without ever being forced. What appears miraculous when condensed becomes ordinary when extended. Finish contributes to misunderstanding as well. Smooth stone is associated today with high-speed cutting. In ancient contexts, smoothness emerged from abrasion and repetition. The surface looks similar. The process was entirely different. The absence of dramatic tool marks is interpreted as absence of tools. In reality, the tools were indirect. Sand, water, wood, and habit leave no signature. The stone conceals the work that produced it. Language reinforces the illusion. Terms like primitive and advanced impose a linear hierarchy that does not fit stonework well. Some ancient methods are better suited to certain goals than modern ones. Dry-fit masonry outperforms mortar in seismic regions. Slow abrasion produces surfaces less prone to microfracture. Sliding heavy loads reduces risk compared to lifting. Progress is not always forward. It branches. The illusion also survives because ancient builders rarely explained themselves. They did not leave manuals detailing technique. They did not frame their work as extraordinary. It was simply how stone was handled. When continuity broke, later societies inherited results without context. The methods appeared unreachable because the habits that sustained them were gone. Modern reconstruction efforts reveal this gap clearly. When builders attempt to replicate ancient stonework using modern assumptions, failure is common. The response is often to assume missing technology rather than mismatched conditions. Modern builders isolate tasks. They separate design from execution. Ancient builders integrated them. The same hands that shaped the stone placed it. Feedback was immediate. Correction occurred continuously. This integration reduces reliance on abstract planning. Adjustments happen on site. The stone dictates decisions. Modern systems prioritize predictability through specification. Ancient systems prioritized responsiveness through attention. Both achieve results. They do so differently. The illusion of loss is also fueled by specialization. Modern societies distribute skills across professions. Engineers design, operators execute, craftspeople finish. Ancient stonework often collapsed these roles. Knowledge traveled with individuals, not documents. When those individuals were gone, the knowledge vanished with them. No archive remained to retrieve. The appeal of lost technology narratives lies partly in their drama. A vanished science feels more compelling than slow habit. It elevates ancient builders into something unknowable. It also absolves modern observers from the effort of understanding mundane processes deeply. Mystery replaces patience. Yet when each component is examined separately, the mystery recedes. Abrasion explains smoothness. Leverage explains movement. Geometry explains alignment. Feedback explains precision. None of these elements are secret. They are simply undervalued in modern narratives. The stones do not demand extraordinary explanations. They demonstrate ordinary principles applied relentlessly. The consistency is what impresses, not the principle itself. What is truly missing is not technology, but context. The social systems that supported slow, careful work no longer dominate. Economies reward speed. Attention is fragmented. Methods that require decades to master struggle to survive. When viewed this way, ancient stonework becomes instructive rather than mysterious. It shows what can be achieved when material behavior is respected and time is allowed to do its work. It challenges modern assumptions about efficiency and progress. It reminds us that some forms of precision emerge only when pressure is removed. The illusion persists because it aligns with modern values. Machines fit our imagination better than patience. Devices feel more plausible than habit. Yet the stone argues otherwise. Its surfaces are calm. Its joints are deliberate. Its placement is confident. These qualities arise from restraint, not force. Understanding this does not diminish ancient achievement. It grounds it. It replaces fantasy with respect. The builders were not magicians. They were attentive practitioners working within constraints they understood deeply. Their advantage lay not in secret tools, but in sustained focus applied across generations. When that focus ended, the results could not be repeated easily. Later builders adapted. They chose different priorities. The stone remained as evidence of what was once ordinary. Over time, the ordinary became extraordinary through neglect. The illusion of lost technology dissolves when the stone is allowed to speak on its own terms. It does not describe vanished machines. It records a way of working that valued control over speed, correction over force, and patience over spectacle. The lesson is not about what was taken away. It is about what was set aside. Stone endures because it resists change. Practices do not. They survive only while practiced. When they fade, the result appears mysterious. In truth, nothing was hidden. The methods were always visible to those willing to slow down and look closely. The stone waits, unchanged, for that attention to return. Stone does not explain itself. It records outcomes, not intentions, and this silence often invites speculation rather than observation. Modern inquiry tends to ask what ancient builders lacked, assuming that absence must be filled by invention. A different approach begins by asking what they relied upon instead. When examined closely, the record shows a consistent preference for systems that minimized risk, favored correction, and allowed error to be absorbed gradually, rather than catastrophically. Ancient builders worked within environments that punished haste. A cracked block represented not only wasted labor, but lost time that could not be recovered quickly. Quarrying, transport, and placement were interdependent. A mistake made early followed the stone to its destination. This reality shaped behavior. Methods evolved to reveal error as soon as possible, when correction was still cheap. Stone fitting, measurement, and movement were therefore continuous processes rather than discrete stages. This continuity is visible in unfinished work. Abandoned blocks in quarries are not rare anomalies. They are evidence of decision-making. Cracks that wandered unpredictably, surfaces that refused alignment, or material that proved unsuitable were left behind. The builders did not force completion. They accepted failure early to preserve the integrity of the whole. This discipline required confidence and patience, not superior tools. The same restraint appears during placement. Stones were not set once and forgotten. They were tested repeatedly. A block eased into position revealed its behavior under gravity. If it rocked or stressed neighboring stones, it was removed and adjusted. This cycle continued until the stone settled naturally. The final position reflects not a single precise act, but accumulated correction. Precision emerges from iteration. Such iteration depends on feedback. Ancient builders relied on senses trained to detect subtle cues. A slight change in sound could indicate internal fracture. A shift in resistance under leverage could signal imbalance. The feel of a rope under tension communicated load distribution instantly. These signals were not abstract measurements. They were embodied experiences learned through repetition. Modern engineering often separates feedback from action. Sensors collect data. Software analyzes it. Decisions follow. Ancient practice collapsed these steps. The builder felt the stone respond directly. Correction followed immediately. This immediacy reduced the need for prediction. The stone itself guided the process. This approach explains why ancient methods appear conservative. Innovation was incremental. A new technique was tested cautiously, applied locally, and repeated only if it proved reliable. Radical change risked failure on a scale that could not be absorbed easily. Over time, this conservatism produced methods that were robust rather than fast. They tolerated variation in material and environment. Material variability mattered. Stone is not uniform even within a single quarry. Grain shifts, inclusions appear, fractures hide beneath the surface. Ancient builders adapted continuously. They did not assume uniform behavior. Each block was treated as a specific case. This responsiveness contrasts with modern standardization, which assumes uniformity and compensates with tolerance and filler. Tolerance itself was understood differently. Ancient stonework often aims for maximum contact rather than perfect flatness. Slight convexity increases stability. Broad contact distributes stress. These choices reflect understanding of long-term behavior rather than immediate appearance. The structure is designed to settle, not to remain rigid. This mindset extends to alignment. Perfect geometric abstraction was less important than functional coherence. Floors were level enough to drain properly. Walls were straight enough to distribute load evenly. Deviations that did not threaten stability were acceptable. Precision served purpose, not ideology. The social organization surrounding construction reinforced this pragmatism. Labor was often seasonal, aligned with agricultural cycles. Large projects absorbed surplus labor rather than competing with food production. This rhythm favored slow, steady progress. Urgency was rare. Time pressure, a defining feature of modern construction, was largely absent. Without urgency, decision-making changed. Builders could wait for favorable conditions. Transport might pause during wet seasons or resume during floods that aided movement. Quarrying could halt if stone quality proved uncertain. This flexibility reduced risk. Modern schedules rarely allow such patience. The absence of written technical manuals reflects this environment. Knowledge was situational. It depended on material, climate, and local practice. Writing such knowledge would have required abstraction that offered little advantage. Demonstration was more efficient. A method shown once could be repeated indefinitely. Writing would have frozen it unnecessarily. When these conditions changed, methods changed with them. As societies centralized, expanded, or militarized, priorities shifted. Speed, scale, and symbolism gained importance. Mortar-based construction allowed faster assembly. Smaller stones reduced transport risk. The trade-off was precision. The stone record shows this transition clearly. What appears to modern eyes as decline may simply be adaptation. Later builders solved different problems. They were not trying to replicate earlier work. They responded to new constraints. The disappearance of certain techniques reflects changing values rather than failure. Understanding this reframes ancient stonework as a product of choice rather than mystery. Builders chose methods that balanced risk, labor, and time according to their context. The results appear extraordinary because modern contexts rarely support similar choices. Attention has shifted. The temptation to imagine lost machines arises because machines align with modern expectations. They concentrate power, accelerate process, and externalize effort. Ancient systems distributed effort. They embedded power in time, coordination, and environment. This distribution leaves little trace. Stone preserves outcome, not process. When process dissolves, outcome appears inexplicable. The gap invites invention. Yet the stone itself resists dramatic explanations. Its surfaces show calm consistency. Its joints reveal dialogue rather than domination. Its placement suggests negotiation with gravity, not conquest. Allowing the stone to speak requires patience, similar to that which shaped it. Quick conclusions mirror the haste ancient builders avoided. Slow observation reveals patterns that accumulate meaning. The same principles appear repeatedly: early correction, distributed force, continuous feedback, and respect for material limits. These principles are not ancient secrets. They remain available. What has changed is the willingness to apply them consistently over long periods. Modern systems value throughput. Ancient systems valued endurance. Stone remembers endurance. The lesson carried forward is not about recovering lost technology. It is about recognizing lost conditions. Precision emerges when attention is sustained and pressure is minimized. When those conditions disappear, the skill fades, even if intelligence remains. Stone stands unchanged, indifferent to interpretation. It does not demand myth. It records a way of working that favored patience over spectacle. Understanding that choice dissolves much of the mystery. What remains is not a lost science, but a quiet reminder of what becomes possible when time is allowed to do its work. Stone, when observed without preconception, reveals a consistent preference for negotiation over domination. Ancient builders did not approach material as something to be conquered quickly. They treated it as a partner whose behavior had to be learned, anticipated, and respected. This attitude shaped not only technique, but decision-making at every stage, from quarry selection to final placement. Quarries were not chosen randomly. Builders studied how stone fractured, how it weathered, how it responded to moisture and heat. A quarry that produced predictable breaks was more valuable than one closer but unreliable. This judgment required experience accumulated over generations. A poor quarry could doom a project before it began. The choice itself functioned as a form of quality control. Once stone was extracted, its behavior continued to dictate method. Blocks that resisted clean separation were abandoned. Those that responded well were prioritized. This selection bias improved outcomes downstream. Only stones that behaved honestly reached construction sites. Precision was not imposed at the end. It was filtered from the beginning. The same logic governed shaping. Rather than forcing stone into abstract ideals, builders adjusted form in response to feedback. Surfaces were tested repeatedly. Contact revealed error. Correction followed. This iterative process resembles tuning rather than manufacturing. Each adjustment responded to what the stone offered rather than to what a plan demanded. This tuning extended to placement. Stones were not dropped into position. They were eased, nudged, tested, and sometimes removed entirely. Final settling mattered more than initial alignment. A stone that rested naturally under gravity remained stable over time. One that was forced into place retained internal stress. Ancient builders favored outcomes that reduced long-term risk, even if they required more effort initially. Modern observers often misinterpret this caution as limitation. In reality, it reflects sophisticated risk assessment. Ancient projects lacked insurance, replacement parts, or rapid repair. Failure carried social and economic consequences. Caution was rational. Methods evolved to minimize irreversible error. This rationality appears clearly in how ancient builders treated time. Time was not a cost to be minimized. It was a resource to be used. Allowing processes to unfold slowly reduced the need for force. Wooden wedges split stone evenly because they expanded gradually. Abrasion produced flatness because it acted consistently. Sliding loads moved safely because speed remained low. Time replaced power. The social structures surrounding construction supported this approach. Labor was often organized seasonally. Agricultural downtime provided manpower. Projects progressed in phases aligned with environmental conditions. Builders waited for floods, dry seasons, or cooler temperatures. These pauses were not inefficiencies. They were strategic. Knowledge transmission adapted to this rhythm. Apprenticeship unfolded over years, not weeks. Skills were learned in context, alongside the material they addressed. Abstract explanation was unnecessary. Demonstration sufficed. The knowledge became embodied, difficult to articulate but reliable in practice. When these social rhythms changed, methods changed with them. Urbanization, militarization, or centralized administration compressed timelines. Construction became symbolic, competitive, or urgent. Under these pressures, slower methods lost favor. Stonework adapted. Precision gave way to speed. The archaeological record reflects this shift clearly. Early phases emphasize careful fitting. Later phases accept filler and mortar. The stone itself records changing tolerance for imperfection. These changes do not indicate ignorance. They indicate different priorities. Misunderstanding arises when later observers treat early precision as evidence of lost science rather than lost patience. The methods were never secret. They were simply incompatible with environments that valued rapid results. When those environments dominate, the methods fade. Modern experiments that attempt to replicate ancient stonework often fail because they reproduce tools, but not conditions. They test copper chisels without years of practice. They impose deadlines that ancient builders never faced. They isolate steps that were once integrated. Failure under these constraints proves little about ancient capability. The illusion of impossibility dissolves when conditions are adjusted. When time pressure is removed, when tasks are integrated, when feedback is immediate, simple methods succeed. The stone responds as it always has. The barrier is not material, it is expectation. Ancient builders expected to work slowly. They expected to correct often. They expected stone to resist. Their methods reflect those expectations. Modern builders expect speed, predictability, and modularity. Their methods reflect those goals. Neither approach is inherently superior. They answer different questions. Stone preservation amplifies this contrast. Ancient structures endure because they were designed to settle into place. Modern structures often depend on maintenance cycles. When maintenance fails, collapse follows. The difference reflects philosophy rather than skill. Understanding ancient stonework therefore requires empathy for a different relationship with time. Precision emerged not from technological advantage, but from alignment between goals, methods, and environment. When that alignment broke, the results could not be sustained. The fascination with lost technology often masks discomfort with this conclusion. It suggests that something external was removed, rather than acknowledging that something internal changed. Patience is harder to recover than machines. Stone does not romanticize its makers. It records choices. Where patience governed, precision followed. Where urgency intruded, tolerance widened. The record is consistent and unambiguous when read carefully. Allowing the stone to guide interpretation replaces speculation with coherence. The methods were not miraculous. They were deliberate. They required conditions that no longer dominate modern life. Recognizing this does not diminish ancient achievement. It clarifies it. The lesson is quiet but persistent. Precision is not produced by tools alone. It emerges from sustained attention applied under conditions that allow error to be addressed before it accumulates. When those conditions disappear, the skill disappears with them. Stone remains as evidence of what becomes possible when material is treated as a partner rather than an obstacle. It does not ask to be mythologized. It asks to be understood on its own terms. Across ancient landscapes, stone structures do more than stand. They persist, often outlasting the societies that raised them, surviving earthquakes, floods, invasions, and neglect. This endurance is frequently attributed to mysterious knowledge or lost technology, yet the explanation lies closer to the ground. Ancient builders designed not for short-term success, but for long-term settlement. Their methods aimed to let stone find equilibrium rather than to hold it rigidly in place. Stability, in this context, was not achieved by locking components together permanently. It was achieved by allowing controlled movement. Dry-fit masonry exemplifies this principle. Stones set without mortar can shift minutely under stress and then return to rest. This behavior is especially visible in seismic regions, where structures built with rigid binders crack and fail, while interlocking stone walls survive repeated shocks. The stones move, but they do not separate. This approach requires precision of a particular kind. Contact surfaces must be carefully shaped to distribute load evenly. High points create stress, low points create voids. Both invite failure. Ancient builders addressed this through repeated fitting rather than through mathematical abstraction. Stones were brought together, tested under gravity, separated, adjusted, and returned. The process continued until the stone settled naturally. Gravity served as the final judge. The result is a structure that behaves more like a system than an object. Each stone contributes to stability through its relationship with neighboring stones. Load is shared. Stress is diffused. No single component carries excessive strain. This distribution explains why many ancient walls grow more stable with time, as minor movements allow stones to seat more securely. Modern construction often aims for immediate rigidity. Mortar, adhesives, and reinforced concrete fix elements in place. This rigidity simplifies construction and speeds completion, but it concentrates stress. When conditions change, thermal expansion, ground movement, or vibration introduce forces the structure cannot absorb. Cracks form. Maintenance becomes necessary. Ancient builders traded speed for adaptability. The choice of stone shape reflects this philosophy. Polygonal blocks with multiple faces resist sliding in any single direction. Curved contact surfaces convert linear force into distributed pressure. These forms are more forgiving than simple rectangles. They require more effort to shape, but they reward that effort with resilience. The geometry responds to physics rather than defying it. Terraces and retaining walls reveal the same logic. At sites like Machu Picchu, walls follow the mountain rather than cutting through it. Stones are arranged to drain water, not trap it. Slight inclines guide moisture away. The structure collaborates with gravity and weather instead of resisting them. This cooperation reduces long-term degradation. Water management plays a central role in durability. Ancient builders understood that water, more than weight, threatens stone. Drainage channels, subtle slopes, and porous joints prevent accumulation. Dry-fit walls allow moisture to escape rather than trapping it. Mortarless construction breathes. Over time, this breathing preserves integrity. Foundation preparation reinforces this system. Rather than pouring flat slabs, ancient builders often layered compacted material beneath structures. This flexible base absorbs movement. When the ground shifts, the structure responds gradually rather than catastrophically. Modern foundations prioritize uniformity. Ancient foundations prioritized behavior. These decisions reflect an understanding of time as an active force. Structures were expected to age, settle, and adapt. Design accounted for this process. Ancient builders did not aim to freeze a moment of perfection. They aimed to guide change along safe paths. The stone was allowed to move just enough to survive. This perspective reframes precision. Accuracy was not about immobility. It was about alignment with long-term forces. A stone placed perfectly for a single moment, but unable to adapt, would fail. A stone placed with tolerance for adjustment endured. Precision, therefore, included flexibility. The social context supported this outlook. Builders worked for communities that expected structures to last indefinitely. Temples, walls, and terraces were not disposable. They anchored identity and memory. Investment in durability made sense. The time required for careful fitting was justified by permanence. As social priorities shifted, this justification weakened. When buildings became symbols of power tied to individual rulers or short political cycles, speed gained importance. Replacement became acceptable. Stonework adapted. The archaeological record reflects this shift clearly in declining joint quality and increased reliance on binders. Misinterpretation arises when modern observers project their own expectations backward. Seeing structures that outlast modern buildings suggests superior technology. In reality, it reflects different goals. Ancient builders optimized for endurance. Modern systems often optimize for efficiency and scalability. Each approach has strengths. They answer different needs. The endurance of ancient stone is therefore not an accident. It is the result of deliberate choices repeated consistently. Those choices prioritized adaptability, drainage, load distribution, and gradual correction. None of these require advanced machines. They require attention, patience, and respect for material behavior. Experimental archaeology supports this view. When modern builders attempt to recreate ancient methods without imposing modern schedules, results improve dramatically. Stones settle. Walls stabilize. The process feels slow but controlled. The same principles apply today when time is allowed to function as a stabilizing force. The persistence of ancient structures invites admiration, but not mystification. They stand because they were allowed to behave like stone. They were not constrained beyond their nature. Stress was managed rather than eliminated. Movement was guided rather than forbidden. Understanding this challenges modern assumptions about progress. Faster is not always better. Stronger is not always safer. Sometimes durability emerges from restraint. Ancient builders understood this intuitively because their environment demanded it. Stone preserves this lesson without commentary. It does not boast of technique. It demonstrates outcome. The survival of these structures is not proof of lost science, but of a philosophy that treated time, gravity, and material as collaborators. When that philosophy faded, the results changed. Buildings still rose, but their relationship with time altered. Maintenance replaced settlement. Repair replaced adaptation. The stone record captures this shift with clarity. The endurance of ancient stonework remains impressive not because it defies explanation, but because it follows a logic modern systems rarely adopt. It asks for patience in a world that rewards speed. It asks for attention where distraction dominates. Stone does not require mystery to command respect. It requires understanding. Its survival is the consequence of choices made slowly and applied consistently. Those choices remain available, but the conditions that support them are increasingly rare. What ancient builders left behind is not a lost technology, but a reminder. Durability is designed, not discovered. It emerges when material is allowed to settle into balance rather than being forced into compliance. Stone, given time, reveals the wisdom of that restraint. The endurance of ancient stonework also reflects a different understanding of failure. In modern construction, failure is often hidden, patched, or postponed. In ancient practice, failure was confronted early and allowed to halt progress entirely. This willingness to stop shaped every stage of stone handling and prevented small errors from becoming irreversible disasters. Quarries reveal this mindset most clearly. Across the ancient world, partially cut blocks lie abandoned where cracks propagated unexpectedly or grain shifted unfavorably. These stones were not completed out of stubbornness or pride. They were left behind because forcing completion would compromise the structure later. The cost of abandonment was accepted as preferable to the cost of collapse. This choice required authority, discipline, and patience. Such restraint extended to design itself. Ancient builders did not assume every stone could be made to work. Designs accommodated variability. Walls thickened where material quality was uncertain. Courses adjusted height to compensate for irregular blocks. The structure adapted to available stone rather than demanding uniformity. This adaptability reduced pressure on individual components. Modern design often reverses this logic. Materials are standardized to fit plans. Deviations are corrected mechanically or concealed. Ancient systems lacked this luxury. Instead, plans evolved in response to material. The structure became a record of negotiation rather than enforcement. This negotiation continued during assembly. Stones were placed tentatively. Their behavior under load was observed. If a block shifted or stressed neighbors, it was removed and reworked. Placement was provisional until gravity confirmed success. Only then was the stone considered complete. This approach contrasts sharply with modern methods that rely on calculations to predict behavior before placement. Prediction played a smaller role in ancient construction. Feedback played a larger one. Builders learned by observing how stone responded in real conditions. This reduced reliance on abstract models and increased reliance on experience. The stone itself became the test. The willingness to remove and redo work challenges modern assumptions about efficiency. Ancient builders accepted rework as part of the process. Time invested in correction early prevented far greater loss later. This philosophy treated construction as iterative rather than linear. Iteration also shaped aesthetics. Ancient stonework often appears organic, responding to terrain and material rather than imposing rigid geometry. Walls curve gently. Courses adjust subtly. These variations are not mistakes. They are evidence of continuous correction guided by observation. Failure was not stigmatized. It was instructive. A cracked block taught limits. An unstable joint revealed imbalance. These lessons were absorbed into practice and transmitted through demonstration. Over time, collective judgment improved. Precision emerged from accumulated experience rather than isolated brilliance. This approach required social structures that tolerated delay. Builders needed permission to stop, reassess, and adjust. Authority supported caution rather than punishing it. When these structures weakened, methods changed. Speed replaced deliberation. Failure became something to hide rather than address openly. The archaeological record reflects this shift. Later constructions often show fewer abandoned stones at quarries, but more compromised joints at sites. Problems were pushed forward rather than resolved early. The structure absorbed risk instead of eliminating it. Ancient builders also understood that stone continues to change after placement. Temperature, moisture, and load alter behavior gradually. Designs allowed for this movement. Joints were shaped to settle rather than lock. Foundations were layered to absorb shifts. These features reflect long-term thinking rooted in observation of previous structures. Modern systems often separate design from lifespan. Structures are engineered for a predicted duration. Maintenance plans replace adaptability. Ancient systems assumed indefinite use. Their designs accounted for aging rather than replacement. The refusal to force stone extended to scale. Monumental projects were broken into manageable phases. Progress was assessed continuously. Adjustments were made between stages. This modularity limited the consequences of error. A mistake in one phase did not doom the entire structure. This phased approach aligns with the absence of rigid schedules. Without deadlines imposed by markets or politics, builders could prioritize correctness over completion. Time served as a buffer against error. Pressure remained low. Misinterpretation arises when modern observers equate slowness with inefficiency. In ancient contexts, slowness was efficiency measured over centuries rather than seasons. A structure that endured required less repair, less replacement, and less resource expenditure over its lifetime. The willingness to abandon flawed work also undermines narratives of lost technology. If ancient builders possessed machines capable of overcoming material resistance easily, abandonment would be unnecessary. The evidence suggests the opposite. They respected limits and worked within them. Stone surfaces preserve traces of this respect. Edges are softened to reduce stress. Corners are eased to prevent fracture. Load paths are broad rather than concentrated. These choices reflect understanding gained through failure rather than abstract theory. The disappearance of these practices does not indicate their inferiority. It reflects changing incentives. When societies prioritize rapid expansion or symbolic display, tolerance for delay diminishes. Methods adapt accordingly. Precision gives way to throughput. Stone records this transition with clarity. Early work shows confidence in patience. Later work shows confidence in filler and reinforcement. Both approaches solve problems. They solve different ones. Understanding ancient stonework requires acknowledging this shift without romanticism. The past was not perfect. It was disciplined. Its achievements rest on systems that allowed failure to be addressed honestly and early. Stone remains as the archive of those decisions. It shows where builders stopped, adjusted, or walked away. These moments of restraint are as important as moments of success. They reveal a culture that valued durability over display. The lesson is subtle but powerful. Precision is not the absence of failure. It is the willingness to confront it before it compounds. Ancient builders understood this through experience. Their stone stands because they allowed it to teach them when to stop. By the time ancient stone methods reached their highest refinement, they were no longer perceived as special by those who used them. They were routine. The quiet mastery visible in surviving structures reflects a stage where technique had become habit, and habit no longer needed explanation. This ordinariness is precisely what makes the methods difficult to recover today. What was once obvious left no reason to be recorded. In cultures where stone construction reached maturity, the builder's attention shifted away from invention and toward consistency. The challenge was not discovering how to work stone, but ensuring that every worker applied the same judgment day after day. Precision depended less on individual brilliance than on collective discipline. A single careless action could undermine months of careful preparation. This discipline shaped how labor was organized. Experienced builders oversaw critical phases: quarry selection, final fitting, alignment. Less experienced workers performed repetitive tasks under supervision. Responsibility increased gradually. No one was rushed into complexity. Skill was layered slowly, reinforced through repetition rather than accelerated through instruction. Such systems resist documentation. Much of the knowledge involved was tacit, embedded in movement and timing. How hard to press during abrasion. When to stop heating stone before fracture becomes unpredictable. How a rope should feel under proper tension. These judgments are difficult to reduce to words. They are learned through correction, not description. This embodied knowledge explains why later societies, even with access to surviving structures, struggled to replicate them. The result could be seen, the process could not. Without years of immersion, imitation remained superficial. Stone was cut flatter, but not fitted better. Mortar compensated where judgment was lacking. The structure stood, but behaved differently over time. The loss of this ordinariness transformed ancient stonework into spectacle. What had once been everyday became exceptional by default. Observers encountering these structures centuries later interpreted them through unfamiliar frameworks. Precision suggested advanced machinery. Smoothness implied speed. Mass implied force. The quiet role of patience was overlooked. Modern narratives often mirror this misunderstanding. Attention gravitates toward what is dramatic. Hypothetical machines, exotic materials, sudden disappearance. The reality is less theatrical. The methods faded because the conditions that sustained them faded. Slow training, long timelines, and tolerance for abandonment became increasingly rare. Economic change played a decisive role. As societies grew more interconnected, construction projects competed with other demands. Time became monetized. Speed acquired value independent of durability. Stonework adapted accordingly. Smaller blocks, modular elements, and binders replaced slow-fitting mass. The results satisfied immediate needs, but altered long-term behavior. Political symbolism reinforced this shift. Buildings became statements of authority tied to individual reigns or events. Completion mattered more than settlement. Structures needed to rise quickly to serve their purpose. The patience required for traditional stone fitting conflicted with these goals. Methods changed not because they failed, but because they no longer fit. Environmental pressure accelerated the transition. Deforestation reduced access to wood for levers and sledges. Soil depletion altered transport paths. Climate shifts disrupted seasonal rhythms. Builders adapted pragmatically. Stonework became lighter, faster, and more forgiving. Precision receded where it no longer offered sufficient advantage. What survives today is therefore a filtered record. We see the best of early practice and the compromises of later adaptation. The contrast exaggerates difference. It creates the illusion of a lost peak rather than a shifting balance. Understanding this balance reframes ancient achievement. Precision was not a singular moment of brilliance. It was the product of sustained alignment between goals, methods, and environment. When alignment broke, the methods unraveled gradually. No catastrophe was required. The stone itself confirms this reading. Where continuity persisted, precision persisted. Where continuity fractured, joints widened, surfaces roughened, and tolerances increased. The transition is visible, measurable, and consistent across regions. This pattern undermines the idea that ancient builders possessed inaccessible secrets. What they possessed was stability. They worked within systems that allowed slow mastery to flourish. Modern societies rarely support such systems at scale. The difference lies in organization, not cognition. Reconstructing ancient methods today therefore requires more than replicating tools. It requires recreating conditions. Time must be available. Error must be acceptable early. Feedback must be immediate. Without these elements, even correct tools produce inferior results. When these conditions are approximated, modern experiments succeed more often than expected. Stones settle, fits improve. The process feels inefficient by modern standards, yet reliable. The ancient logic reasserts itself naturally. The endurance of ancient stone structures thus becomes less mysterious and more instructive. They demonstrate what happens when material is treated with restraint and attention over extended periods. They show how precision can emerge without spectacle. What is lost is not knowledge, but patience institutionalized. Recovering the results without recovering the conditions remains difficult. Stone stands as evidence of a mode of working that valued continuity over novelty and settlement over speed. This understanding strips away romance without diminishing achievement. Ancient builders were not superhuman. They were persistent. Their skill rested on repetition, supported by social systems that allowed it to deepen across generations. Stone remains because it rewards such persistence. It does not respond to haste. It does not forgive arrogance. It yields slowly to those willing to listen. The structures that endure are monuments not to forgotten machines, but to a way of working that modern life rarely permits. The quiet mastery embedded in ancient stone invites reflection rather than myth. It asks not how such work was possible, but why the conditions that made it ordinary are no longer common. The answer lies not in lost technology, but in choices made over time, written silently into the stone itself. As ancient stone traditions approached their final stages of continuity, the work itself began to change character. What had once been embedded in daily practice slowly detached from lived experience. Builders still handled stone, but the relationship grew more transactional. The stone was no longer something to converse with over years, but something to manage within constraints that were tightening around time, labor, and purpose. This shift is visible in how projects were conceived. Earlier structures often evolved organically, expanding or adjusting over decades. Later projects tended to be conceived as complete forms from the outset. The emphasis moved toward completion rather than settlement. A building needed to stand visibly finished, even if its internal stresses had not fully resolved. This altered how stone was treated. Where patience once guided fitting, tolerance began to replace it. Mortar, filler, and binding agents grew more common, not because they were superior, but because they accelerated closure. Gaps no longer demanded correction through reworking stone. They could be filled. The surface appearance remained acceptable, but the underlying dialogue between stones diminished. This change did not happen suddenly or universally. It crept in unevenly. Some builders retained older habits longer than others. In many regions, master craftsmen trained under older systems worked alongside younger laborers accustomed to faster methods. The resulting structures reveal this tension. Portions display careful fit, while adjacent sections reveal compromise. Stone records these overlapping traditions clearly. Economic pressures played a central role. As trade expanded and resources were redistributed, construction competed with other priorities. Labor became more expensive. Time became measurable in new ways. The cost of waiting increased. Stonework adapted by favoring predictability over perfection. Smaller blocks reduced risk. Standardized shapes simplified planning. The stone ceased to be unique and became modular. This modularity altered how failure was handled. In earlier practice, a flawed stone halted progress. In later systems, flawed stones could be replaced easily or compensated for. The structure absorbed imperfection. This resilience favored speed, but it also masked problems that would once have demanded attention. The cultural meaning of buildings also shifted. Structures increasingly served as markers of authority, wealth, or identity tied to specific moments. Their role was symbolic as much as functional. Longevity remained desirable, but it no longer justified unlimited investment of time. A building that endured long enough to assert legitimacy had fulfilled its purpose. Under these conditions, older stone methods became impractical. Apprenticeship shortened, skills were simplified. Knowledge that once took decades to internalize was condensed into repeatable procedures. The result was competence without mastery. Buildings stood, but their relationship with time changed. Stone surfaces reflect this transition. Earlier work shows subtle curvature, eased edges, and careful contact. Later work favors flatness achieved quickly. Joints widen. Regularity replaces responsiveness. The stone behaves differently under stress. Repairs become more frequent. The difference is not dramatic at first, but it accumulates. The disappearance of older methods was therefore not an accident. It was a response. Builders adapted rationally to new incentives. Precision that required patience lost value in systems that rewarded speed. The methods faded because they no longer fit. Later observers encountering the results without context misread this fading as loss. The earlier structures appeared unreachable. The later ones appeared inferior. The explanation seemed to require a vanished capability. In reality, the capability still existed in fragments, but the environment that supported it had eroded. This erosion extended beyond construction. It reflected broader changes in how societies related to time. Cycles shortened, horizons narrowed, long-term settlement gave way to short-term completion. Stonework mirrored this shift faithfully. Attempts to revive older methods often stumble on this same obstacle. Tools can be reconstructed. Techniques can be demonstrated. What proves difficult is sustaining the process long enough for mastery to emerge. Without institutional support for patience, the results remain partial. Modern craftspeople who dedicate themselves to stone over decades demonstrate that the skill is not lost. It is rare. It survives at the margins, where time can still be invested deeply. Their work confirms what the stone suggests. The methods remain possible. The conditions remain uncommon. The fascination with ancient stone thus reflects a tension between admiration and unfamiliarity. The work feels alien because it emerges from priorities that no longer dominate. It asks for commitment beyond immediate return. It rewards attention rather than acceleration. Understanding this does not require romanticizing the past. Ancient builders faced hardships modern societies have overcome. Their methods were shaped by necessity as much as choice. What they achieved reflects alignment between need and method that modern systems rarely recreate. Stone stands as evidence of that alignment. Its endurance is not an accident or a miracle. It is the outcome of decisions made consistently over long periods. When those decisions changed, the outcomes changed with them. The final stages of ancient stone traditions did not end in catastrophe. They dissolved gradually into new forms. Skills were simplified, redirected, or absorbed into different practices. What remained was enough to build, but not enough to reproduce earlier refinement easily. This gradual dissolution explains why no single moment marks the end. There is no clear boundary between mastery and loss. There is only a shifting balance between patience and pressure. Stone records that balance silently. The lesson carried forward is not about recovering a vanished golden age. It is about recognizing the conditions that made such work ordinary. Precision at this scale is not mysterious. It is demanding. It requires environments willing to support slow learning and careful correction. When those environments disappear, the work appears miraculous in hindsight. The stone remains, indifferent to interpretation, carrying the imprint of a way of working that valued endurance over immediacy. The ancient world did not hide its methods. It lived them. When living conditions changed, the methods changed too. Stone preserves the trace of that transformation with unwavering clarity, inviting careful reading rather than speculation. Nothing in the ancient world announced an ending. There was no moment when stone knowledge collapsed, no single generation that forgot how to listen to material. The change unfolded quietly, carried by altered priorities rather than catastrophe. Builders continued to work stone, but the conditions that once shaped their patience narrowed, and the relationship shifted almost without notice. Earlier traditions treated stone as something that required time to settle into balance. Placement was provisional until gravity confirmed success. Weight was invited to speak before permanence was declared. Over time, this expectation softened. Structures increasingly aimed for completion rather than settlement. A building that stood upright and appeared finished satisfied new demands, even if its deeper behavior remained untested. This transition altered how stone was understood. Where stone had once been approached as a collaborator with its own tendencies, it increasingly became a component to be managed. Mortar, binders, and reinforcement did not replace ignorance with knowledge. They replaced dialogue with control. The stone still served its purpose, but the conversation shortened. The archaeological record magnifies this shift by preserving extremes. What survives most clearly is the peak of earlier practice and the compromises of later adaptation. The ordinary middle ground erodes. As a result, the contrast feels sharper than it truly was. Ancient mastery appears unreachable because its context is missing, not because its methods vanished suddenly. As timelines compressed, patience lost institutional support. Long apprenticeships became difficult to justify. Projects spanning generations conflicted with political and economic cycles that demanded visible results. Stonework adapted rationally. Smaller blocks reduced risk. Standardized shapes simplified planning. Completion became a priority that outweighed refinement. This adaptation did not make later builders less capable. It made them responsive to different pressures. Their structures met the needs of their time. The cost was a gradual reduction in behaviors that favored long-term settlement. Stone still endured, but its endurance increasingly depended on maintenance rather than intrinsic balance. The illusion of lost mastery emerges when later observers judge ancient results through modern expectations. Smooth joints suggest machines. Massive blocks suggest overwhelming force. Precision suggests secret knowledge. The simpler explanation, sustained attention supported by time, feels implausible because it conflicts with contemporary experience. Stone itself resists these fantasies. Its surfaces reveal incremental adjustment rather than rapid cutting. Its joints show repeated correction rather than decisive placement. Its foundations reflect accommodation to ground movement rather than rigid imposition. Everything about the work speaks of persistence rather than spectacle. Modern reconstruction attempts often fail because they recreate tools without recreating conditions. Copper, rope, and stone are assembled, but time is withheld. Practice is abbreviated. Error is tolerated late rather than early. The results disappoint, and the disappointment is misread as evidence of missing technology. When conditions shift, results shift predictably. Experiments that remove time pressure, allow correction, and integrate feedback succeed far more often. Stones settle. Fits improve. The process feels slow but controlled. The ancient logic reasserts itself without mystery. This demonstrates that the knowledge was never locked away. It remains available wherever patience can be institutionalized. What is rare is not understanding, but willingness to organize work around long horizons. Ancient societies did so out of necessity. Modern societies rarely do so by choice. Stone does not reward urgency. It responds honestly to sustained effort and resists shortcuts. Ancient builders accepted these terms because alternatives were limited. Modern systems often attempt to renegotiate them through power, speed, and abstraction. The results differ accordingly. The endurance of ancient structures therefore reflects philosophy more than technology. Builders assumed that structures should age gracefully, not be replaced easily. They designed for settlement rather than stasis. They allowed stone to move just enough to remain stable. Over time, this flexibility became strength. Later systems often reversed this assumption. Structures were expected to perform immediately. Longevity became a managed outcome rather than an inherent one. Maintenance replaced settlement. Repair replaced adaptation. Stone still functioned, but differently. Nothing about this transition requires loss or decline in intelligence. It reflects changing relationships with time. Ancient builders invested time up front. Modern builders distribute time across a structure's lifespan. Each approach carries consequences. The fascination with lost technology often masks discomfort with this conclusion. It suggests that something external disappeared, rather than acknowledging that something internal shifted. Patience is harder to mythologize than machines. Stone itself refuses drama. It does not commemorate endings. It preserves behavior. Where attention accumulated, precision followed. Where pressure increased, tolerance widened. The record is consistent across cultures and centuries. Understanding this dissolves the final mystery. Ancient stonework was not the product of unreachable knowledge. It was the product of sustained alignment between material, method, and social structure. When that alignment weakened, the results changed naturally. The stone that remains is not a riddle. It is a ledger. It records choices made over long periods, written in durable material. Reading it carefully replaces speculation with clarity. The ancient world did not hide its methods from the future. It practiced them openly until conditions no longer supported their continuation. What remains is not a secret, but a reminder of what becomes possible when time is allowed to function as a tool. Stone waits without urgency. It always has. It carries forward the memory of a way of working that valued endurance over immediacy, correction over force, and settlement over display. That memory does not demand recovery. It demands recognition. The final lesson preserved in ancient stone is not technical, but cultural. Precision at this scale emerges when societies choose to support it. When they do not, stone adapts quietly, just as it always has.